Welcome everybody to the OpenUSD Insiders live stream. Technically, this is the Isaac Sim office hours. As you can see, my great colleagues here, Eric Bowman, aka Strainflow, and Rishab. How you doing, guys?
Doing
We
great.
are we are
Doing
going to
good.
cover something super exciting today, gentlemen. Right?
Yes.
This is a very exciting day because we are going to be going through a preview of Isaac Sim 5.0. And it is a preview, meaning that it's still a work in progress, but we're going to show you a little bit under the hood. And we're going to show you how to find out more about it and how you can start working with it right away. We'll get all to that. I'll get into all that in just a minute. I want to cover a couple things really quick regarding some announcements that just came out of Automatica. As you can see on the screen, there's a QR code that'll bring you right to this post about NVIDIA and its partners as we highlight the next generation of robotics, automation, and AI technologies. This is a great blog that covers everything that we just did at Automatica. I highly recommend people check that out. And then we also have making industrial robots more nimble with NVIDIA Isaac Manipulator and Vention Machine Motion AI. Actually, do either one of you gentlemen, do you want to cover Isaac Manipulator at all? Just give a quick heads up on what it is. Are you familiar with it?
Sure. I think at a higher level we can give a quick preview. I don't think like we've got slides or
That's
anything from
okay.
our end, but
Yeah, just
yeah.
a general
I
overview.
think Isaac Manipulator basically consists of GPU accelerated packages designed specifically for manipulation related tasks, and it's based on ROS. So it's like you have Isaac ROS as the fundamental layer, which is responsible for like making sure like the packages are optimized for ROS on GPUs. So it will run with like Jetson, for example, with Orin and the newer Thor version, which is also going to come down soon, and also on desktop GPUs as well as data center GPUs, similar to Isaacson. So you've got accelerated ROS packages fundamentally designed for manipulation-related tasks. So things like grasping, motion planning with QMotion, stuff like that. All of that sort of falls under Isaac Manipulator and is accelerated end-to-end on the GPU through Isaac ROS. So we
I
can do a deeper dive, I guess, if
That's
people are
great.
interested more into it. But
well,
yeah.
and I think if you're in manipulation, it's you just move it, right? Or
Yeah,
it works with, or it
QMotion,
works with.
sure.
Is
Yep.
that
So
right?
QMotion is the motion planner for manipulators, which is being used, which is as well as like from the name you can understand it's CUDA accelerated. So you can use that, and that can be used as like a plugin with MoveIt. So you can have like QMotion as your planner, which plugs into MoveIt and is responsible for like motion planning for particular manipulators. And then we've got like foundation pose, foundation grasp, and related algorithms, foundation models for actually the pose estimation and grasping purposes related to manipulation. So
Now,
connecting all
foundation
of
pose is actually like an AI model, right?
yep,
Right.
it's entirely, I think it's like more than 70-80% on synthetic data trained models, both foundation pose as well as foundation grasp, and they're basically responsible for like estimating the pose for the objects in the field of view of the camera. And once you estimate the pose, then you need to figure out how you grasp it. And for grasping it, then you need to have like motion planning of the manipulator running to do that. So
Now the
all
motion plan
those
is not AI based. That's like a traditional
no,
motion.
yeah,
Is that
that
right?
I
Yeah.
I think QMotion is not AI based. We can certainly check that out for sure, but it
Now,
is accelerated on the GPU specifically, but it isn't AI based. It's like I think deterministic motion planner.
yeah, and the way I remember it is a deterministic motion planning algorithm. And on traditionally, when you use one of those, you have to start with some number of kind of seed kind of options,
Yeah.
and and you might be able to start like with I don't know 5 or 10 or 100 at once. But the cool thing about GPU accelerating is you can start with like a few thousand seeds at once, just
Yeah,
like,
yeah.
and so they can solve it almost in real time because of the acceleration. Yeah.
Right, and I think that just makes it faster and even like smoother motion in general, because even from like the motion planning perspective for manipulators, there are things which you optimize against. So like things like jerk, smooth motion, and maybe time for elapsed motion, then even maybe like distance, like from getting to point A to point B, there are probably different ways to go. It could be one of them could be jerky, one of them could be like a longer path for the manipulator overall. So there are various parameters which can be tweaked so that like your optimization at the back which is running to make sure like the path from A to B is being planned is what you want. So I think QMotion has like plugins which support all of that, and that at a higher level connects into like the whole Isaac manipulator framework where you've got all those pieces together for like achieving the end-to-end task of manipulation from the robotics side.
Amazing. That's super helpful. Okay, so I encourage everybody to check out that QR code. We're going to get into Isaac Sim 5 preview in just a second. The last thing I want to share with everybody, because it's super exciting and literally coming up in next month, we've got SIGGRAPH and Vancouver, Canada, and I will be there. Amelia, our producer, will be there. The community team, lots of developers from video will be there.
I think I'm going to be there as well.
You'll be
So
there.
it should be fun.
Amazing. Fantastic.
Sure, if I'll be or not, but
All right, fingers crossed that Strainflow is going to be there.
and I tell you what, Vancouver in August is delightful.
I heard it's one of the most beautiful places on earth.
If you can find an excuse to come out just to experience Vancouver in August,
and for all the developers out there working on robotics, NVIDIA is going to be leaning heavily into robotics there and physical AI. It's going to be a really fantastic conference for you to network with other developers, get some great content from the sessions, workshops. We have a great OpenUSD meetup planned. So this is happening August 10th to 14th. We actually have a code that our producer Amelia will paste in the chat that gives you a free Expo Pass. So you don't need to pay for the Expo Pass. And also that actually comes with a bunch of free access as well. So we'll list the things that code will give you in a second. But the webpage we'll also paste is full of information about the address that's happening. We have special events, as I mentioned. There will be an Educators Day for schools, a Rendering Day, which is super exciting, an OpenUSD Day, which will have the OpenUSD meetup, as I mentioned. We have the hands-on labs if you want to get certification. Many great presentations regarding the research papers, programs for educators, developers, creators, startups, designers. And we have a great area for people looking to jumpstart their career. So highly recommend people go to SIGGRAPH if you're able to. We're going to set up a channel. Actually, we already have the channel set up on our Discord server called SIGGRAPH. So we're going to post information through up until leading to SIGGRAPH, and then during SIGGRAPH, we'll be posting updates there. We're going to do our best to provide also a live stream during the SIGGRAPH. We're planning the logistics of that right now. Either way, we're going to be posting daily updates. If you are going, we also have a WhatsApp group specifically for on-site attendees, and that's where we can chat in real time about what's coming up each day, meet for coffee, meet for lunch, grab a bite to eat, and just have some fun together at SIGGRAPH 2025. Okay, so that is SIGGRAPH. I'm super excited. Also very excited for today's content because we are diving into Isaac Sim 5. So we're talking a little bit about this in the warm-up. Isaac Sim 5 is pretty exciting. It's not exactly out for the public in terms of official release. It's kind of a preview right now, right? Which means it's still a work in progress. Relatively open source with a couple of caveats there. But Eric and Rishabh, why don't you kind of go over the high level of what Isaac Sim 5 is all about?
Sure. I think we can get started with that. Eric, do you want to give an overview in general, or I can share my screen? What I was planning for is we have the GitHub, which has been open sourced for Isaac Sim, and it's actively under development. So we can have a quick walkthrough of the source code over there and basically how the build stuff works in terms of cloning the repo, building Isaac Sim, adding your own extensions, and looking at the current existing scripts, source code, stuff like that. And we also had a couple of blogs which went out with the release of Isaac Sim at the time of Computex and I think GTC Paris as well. So we had a couple of blogs which highlight the main new features which are a part of Isaac Sim. So I was planning to cover a little bit of Cosmos Replicator Writer as well, which is going to be fun to see how that works with the latest release of Isaac Sim. So I can share my screen or
That sounds perfect.
What do you guys think? Sounds good?
That sounds
Okay.
perfect.
Yeah, go ahead.
Hopefully that's going to work.
Fingers crossed. Okay, and while Rishabh's getting that ready, please definitely let us know. I see some great comments in. I see a couple people attending SIGGRAPH, which is fantastic. Please get in touch with us so we can share some news from the ground. Feel free to share your project, any Isaac Sim related questions. This is of office hours for all the developers out there to help you in your work. So let us know how we can help you. But we're going to cover Isaac Sim, but we definitely want to answer all your other Isaac Sim questions. So feel free to post away, whether or not it's related to Isaac Sim 5.
And I saw one question that I wanted to address early on, which was
go ahead.
someone asked if Isaac Sim 5.0 will be compatible with the new Blackwell GPUs? And the answer is yes. Is
Drum
that
roll.
right?
Awesome.
And
Quick drum roll.
in fact, yeah. And I actually just got my Blackwell workstation in today. And so I'm starting to get that set up. And so
Nice.
hopefully here in a few weeks, I'll be able to do a screenshot of Isaac Sim 5.0 running on a Blackwell GPU. So
Amazing.
yeah.
That's great. Yeah, it's super
Yep.
important, obviously, to support Blackwell.
Thanks, Eric, for getting that question. I think I saw it as well. Like with Blackwell, there was an issue which was raised on the forums with like a rendering glitch where the GUI was a little blurry for 4.5 with the Blackwell cards, but that's been fixed in 5.0. So even with the current repo which we have open right here on our screen, where if you follow the steps and you're able to build it on your system, as long as you've got like the right GPUs, drivers, and like the installation stuff set up on your end, you should be able to run it on a Blackwell card without any issues. So uh, the IsaacSim repo has already been open source. So it went out like a couple of weeks ago. It's like if you look at the repository right here, it's been like 2 to 3 weeks. And it is pretty comprehensive in terms of like the README, which is provided with the repo as well. So I think this is something which we're just talking about. It is that this is pre-release software, so it's still actively under development from the IsaacSim team. So there are any issues or bugs, then there are hyperlinks attached on the README itself where you can hop over there, or you can open up a GitHub issue where the team will be actively involved in addressing those problems which you can see. So that's the way to go. And if we actually look at the other things in the README, it's basically talking about similar things which we've already seen on the IsaacSim documentation, where at a high level you've got assets which can be imported using a different importer. So you've got URDF importer, Mujoko importer, regular CAD importers, and you've also got exporters corresponding to them, which can help you import and export data into IsaacSim so that you have like your robots represented in USD and you're able to do everything inside the IsaacSim world. Guides for robot tuning have also been added, and that is something which we'll also be looking at from the docs perspective. The docs are also actively under development. Let me actually go ahead and open them up too. So it's the same website for the docs as well. So you'll see that a 5.0 branch is still actively under development, like we saw even on the GitHub, that it's work in progress. You might find a few places which are not currently completely up to date. So those are like actively being worked on. But for most of the other docs which sort of carried away from like the 4.5 release, for example, those are pretty much the same. So you'll be able to find them. But you can basically just select which version of the documentation you want to look at, and you should be able to find the corresponding ones here. So what is IsaacSim? And you'll get the 4.5 document. So once you've selected a particular document version, that is entirely applied for the whole website, basically for your documentation. So you don't need to worry about like, oh, is this a 4.5 or 5.0 documentation? The one which is selected is probably the one which is going to be shown end to end on the website. So we are going to select 5.0 for now, and let's actually go and look at the installation steps directly. Like I would encourage developers to go through the process of like reading at a high level what the key features are and the applications are. But if you've already used IsaacSim in the past, I think you're already familiar with most of the things here, like bringing in your assets, tuning robots, simulating them, then maybe using Replicator for synthetic data generation. So you probably already have a higher level understanding of these concepts in general. And now with the source code also actually being available on the repo itself, you can go deeper and understand how things are implemented at the back end. So for example, if you remember, like when we had the previous office hours for Isaacson, where we talked about omnigraph nodes and action graphs, we can actually go into like the source code for ROS2 as well from the bridge perspective and look at the different implementations for omnigraph nodes as well over there. So that can be interesting. Got the documentation linked right here and the prerequisites along with the environment setup things here. So ideally, operating system still which is supported is Ubuntu 22. Ubuntu 24 also probably is going to be supported because like if you're using ROS2, for example, like the recommended version which is supported right now is Humble. But with 24.04 with Ubuntu, it's going to be Jazzy. So both will be supported moving ahead, and
Is ROS
22.
2 Jazzy, has that been released?
Yeah,
or is that
I
up and
think
coming?
that should be released. Because 24 dot. Yep.
And that supports 2404.
Yes.
And I think the last piece of this robotics puzzle for me would be what version of Ubuntu is the latest version of Jetpack on?
That's a good
You know,
question. That I
because
think
those are the three for me. It's you got Isaac Sim, Ross, and Jetpack.
yep,
And
that is correct, because I think like at the end of the day, if you are going to be deploying anything on a real robot and you're going to be like using ROS in any part of your entire framework, you want to make sure that it's correctly supported on Jetpack as well, so that you can have the corresponding versions replicated correctly. Because I think ROS to Jazzy is going to be supported with an upcoming release of Isaac ROS, but that is something we should certainly check and circle back on. But even if it's not directly supported with Isaac ROS, as long as it's based on Ubuntu 24, you might be able to like apt-get install Jazzy directly onto your Jetson, or if not, then build from source is always the other option, which users can do depending on if there's a version mismatch between like ROS, Ubuntu, and maybe even Python, which turns out to be problems in case there is something going on there.
yeah, and I also know that you can run like a containerized versions, like a containerized Jetpack.
Containers certainly do help over there as well. Like building from sources is is not very easy at times, depending on what sort of platform you're using, or if you've got dependency issues as well. And that is something even from, for example, like the IsaacSim documentation highlights itself. It's like there were issues related to like a certain version of compiler being supported from the IsaacSim side for Ubuntu
Yeah,
24. So you want to make sure like your GCC and G++ versions, for example, are 11, not 12, which might be the default for 24. So that
yeah.
is
Well,
being highlighted in the README as well.
and I'd even say like if right now it looks like Jetpack is kind of the holdout for 22.02 or and or 2204, but
Mhm.
you could even just develop on 2404
Yep,
and then just deploy your code to your Jetson and or have just like a build system that's on 2204 so that you can just
makes sense.
primarily work in 24.
Right. Or otherwise, I think like the other option could also be like if there isn't direct support, and that's like a higher priority right now for someone, is like you mentioned, containers make life easier. So using that base container and actually building your source code over there for a particular ROS version might be a way to go for the short term. And I'm pretty sure like within the coming few weeks, or like if we actually circle back and check that it's already available, then it should be doable even today.
Yeah, and yeah, and I would say that because I get this question a lot, right? Why? When are you going to support 24.04? And I think that it's or or when should I switch to 24.04? And I think that it might be time. And
Yep,
I haven't tried it myself, but
yep,
it's about there.
makes sense. Yeah,
And I think, and I also say it's with Windows, you typically use, just so you know, you'll use Windows with Windows subsystem for Linux,
WSL. Yeah,
which works. Um, and the last time I did that, Windows subsystem for Linux could not display graphics. And so basically you'd have Isaac Sim installed directly in the Windows system, and you'd have ROS installed in Windows subsystem for Linux. And then there were some firewall kind of hoops you had to jump
yeah, yep,
to
yep.
get
I
ROS to talk
Yeah.
to get WSL to talk to Windows.
Yeah, I
And
remember like trying experiments even from my end. I think like this was like more than a year ago, where you have like Isaac Sim running in Windows, for example, with the ROS to bridge enabled. And if you've gone through like the build process for ROS on Windows and realize life is painful, then you probably switch to WSL, and that's where like you had like your ROS setup. But actually getting like a Windows ROS based application talking to a Linux one in the same subsystem is just not as
it's
straightforward
non-trivial.
as it seems.
Yeah.
So yeah.
And then of course Jetpack is only on Linux. It's not on Windows.
Yep.
And
Yep.
and really ROS 2 is on Linux, but then you can just get it to work on Windows to WSL.
Yeah.
And Isaac Lab is on Linux, but not on really on I in theory, you can. I think you can get Isaac Lab working on Windows,
You
but
should
there
be
are
able to get Isaac Lab working on Windows as well, I guess, in theory, because like if Isaac Sim is supported directly on Windows, then you can build Isaac Sim. I think for the
right.
Simlink stuff, you probably might be able to like even get Isaac Lab working there. But yeah, if there are feature gaps between Windows and Linux and that's not like officially supported, then might run into problems over there, which will be difficult to debug.
But I would say if you really want to be on Windows, the thing to watch out for is I've heard that, and maybe it's already happened, but I've heard that in Windows at some point they're going to start to support graphics in WSL.
Hmm. Interesting.
And
I'm not
if
up to
that
date with
happens,
that.
yeah, if that happens, then you would be able to just install Isaac Sim and basically work in that Linux environment on your Windows machine completely.
Yeah,
And then I think you wouldn't have all those issues. Anyway,
fair
just
enough.
I the whole OS thing, I've had my fair share of trouble with that, and so I just wanted to
Yeah.
make it clear to
We have
people.
a quick question that kind of ties in nicely to this. Do you envision that the minimum requirements will change much from what we see now and when it's actually officially released?
So I think like the current README is pretty up to date in terms of what the requirements are going to look like. So that should not change, but there might be a slight change from like 4.5 to 5, which is like the general version to version change. But with the current documentation for 5.0, that should not be changing for at least like the installation, build stuff, and most of the other things which are needed for even like getting started.
Great. Okay. So
And
that
I would just add that our minimum requirements are geared towards a decent experience. So, and if you have less than the minimum requirements, I would still give
here
it a
you go.
try
Yeah.
and see how far you can get. But just keep in mind that I think you'll hit some roadblocks, and you'll want to go ahead and upgrade. Um, kind of be ready to upgrade. And at first, I felt a little bad about that, recommending that. And then I actually looked at GPU prices online, and it's interesting that the 50 series GPUs really don't cost more than the 40 and 30 series GPUs. I don't know why that is, but my recommendation is just try to keep up with the latest generation, because you kind of have the two sides of the GPU. You kind of have like how fast does it compute, and then you have how much memory does it have, how much VRAM. And you're going to be able to limp along as long as you have enough VRAM, but you're going to have a lot better experience if you have that faster compute of the later generation GPUs.
That
So
makes sense.
that's
Uh,
that's my two
good
cents.
advice. That's good guidance. Thanks for that question.
And since they don't cost more, like why wouldn't you get the new one?
And I, just quickly circling back on the ROS2 stuff, I think which you were just discussing earlier, Eric, I think like, so even with the 5.0 documentation, there is now a Windows section where we've got official support for WSL2. So I would certainly recommend for people who are using Windows to try out this, where you can have WSL installed on your subsystem and you set up all the IPs correctly, which I think like Eric and I were just discussing is non-trivial, but
It is.
you've got
Yeah.
documentation for that, which is going to be tested thoroughly. So that should work. And if you are tied to Windows for simulation, but still want to use ROS2 and prefer using Linux for that, we still got a solution for you, which is officially supported. So would certainly recommend to check this out. And as usual, if you run into issues or there anything, forums or GitHub issues are the place to go.
Yeah, and I had a fun comment that 32 gigabytes of VRAM is crazy, and the uh, the the new RTX 6000 Pro has 96 gigabytes of
It's
Wow.
VRAM
crazy.
in
You know,
one.
what do you think? So I'm so glad Commodity's watching. A
Mhm.
great developer from Amazon, but he has good advice here too, right? You can leverage the cloud.
Yeah, sure.
Yeah. Oh yeah.
That's always good advice to get started.
So glad he's here. Such
Great
a great.
advice.
Thanks for
And
joining us.
someone else mentioned Brev, which is another way of
Yep,
using the cloud,
Brev
right?
is another way. Yep.
And Brev is really cool.
I
It's a
think
way you can kind
that's
of go ahead.
right. That's something which is also covered in the tech blog which went out with Computex, where launchables for Isaac Sim and Isaac Lab are also going to be available soon. So it's going to be like one-click deployment and getting started with Isaac Sim and Isaac Lab in the cloud. So we'll keep you guys posted in terms of how things are going there, but that's on the roadmap in terms of coming out pretty soon as well.
Amazing.
So you can get started quickly with Brev, and it's going to be like just a one-click launchable where you have your Isaac Sim environment spun up over there. You have the GUI also being rendered to you, and instead of like having the entire local setup with the installation and the build going on locally, that is something you can do directly in the cloud. So using Brev or using other CSPs is something which you could look at
Yeah.
if you don't really have the required system level hardware which is needed for running Isaac Sim or Isaac Lab.
It's great.
I
It's
think of
wonderful.
Rev kind of like the GeForce Now for like enterprise apps, because with GeForce Now, you just log in and launch a game, and it's just like it's just in your browser, and it's really
Beautiful.
cool. And Brev is kind of like that, where you don't have to, it's not like you don't have to, set aside a computer and install everything yourself. It's just kind of all set up for you.
Yep.
Oh, I see. Omniverse Ambassador, Murmar Bay, aka Lychee AI, watching. Hey, Murmar, nice to see you here.
Oh yeah,
I think you really wants to try Brev's one-click launchable. So useful for workshops and training.
agree completely.
Yep.
So yeah,
So I think
so I think there are a lot of options to get,
get started.
oh yeah,
Yeah, there are a lot of options for sure. So I think the GitHub README itself for IsaacSim is pretty self-explanatory in terms of how to get started, making sure you've got like the right hardware and you've got the driver versions also which are appropriate. So everything is linked right here in terms of like the prerequisites for actually building IsaacSim. And once that is done, I think it is pretty straightforward in terms of having the right build tools, which is just going to be installed through right here. And once you've done that, we can actually go through the quick start menu right here. So I've already cloned the repo, but I can walk through like the build process also when we actually have Isaac Sim being built, and we can walk through a bit of the source code and post building in terms of like the structure for release files, build files, and stuff like that. So let's actually bring that terminal up. So yep, this is so maybe I can close this one on the side. Might be too much screen real estate. Yep. So we have this terminal open right here. I'm gonna look. So this basically contains the cloned repo from the GitHub which we were just looking at, and the way to get started with build is straightforward. There are a couple of flags which you can tweak for the build if you want to build like only debug version or release version, or if you want to build in such a way that you only pull in the dependencies which are needed for Isaacson, but don't actually go into the process of like compiling your code and linking it. So there are various flags over there which can be specified, and for that, the best place to actually understand what the build options look like is in the section right here, which is the advanced build option. So can clean the repository exit, you can do a full rebuild entirely, and configuration options and advanced options as well. Uh, Release debug options like stuff which I was talking about earlier, there are flags corresponding to them. So you can use those ones and build the ones which you need. So I'm going to do a
that's
full
a
build. Yep, sorry,
recommended
yeah, go.
command line, like build command in that documentation, right? Just kind of like your default.
Yep.
Okay.
So build.sh /build.sh should be the default, and
Oh,
correspondingly for Windows it'll be build.bat. But yeah, sh and bat are interchangeable from Linux Windows side,
too
but
easy.
not really, but sure. Okay, so this build is going to look relatively faster because the first time when you actually do build Isaac Sim from scratch, it's going to be pulling in all the dependencies from Git, from your physics stuff for replicator. So all your
Oh,
external extensions and the dependencies are going to be pulled in. So that build process takes a long time. This took like 10 seconds because like the dependencies are already there, and we've not actually gone ahead and changed any source code. So it was like a pretty fast build because nothing changed. So it was straightforward enough. So once you sorry, go ahead.
I probably just recognized that it was already built, right?
Yep. So if you actually like, I'm not sure if I would want to do that, but we can have like a clean rebuild that might take a while. So I had it built right here. It might take like more than 10 minutes ish. So if you
Well, if
want
we've
to
got to
do
fill
that, we
some
can.
time at the end, then we'll do the clean
Sure.
build.
Yeah.
Right?
Yeah. 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 Just a heads up, I didn't run into issues. Like that's not why I'm not showing it here, but it just takes a while for the first time. So even this time, it might not take too long because like we have the dependencies already pulled in. So the dependencies exist. It's just the build step where it's going to be compiling the code entirely. That's going to be redone. Right now, it can see that nothing changed and everything was cached earlier. So the build process just flies by. But if you want to rebuild and clean things up, then it'll take a bit longer. So you got your build set up, and let's actually go ahead and look at the file structure right here. Let me, not this one, and not this one either. Let me bring this up right here. So I'm going to go into ISXM GitHub right here, and you'll see an underscore build folder, which has now been generated after like your build is complete. So we're going to go right there, and we're going to select our operating system right here. In our case, it's Linux, so I'm going to go right here. If you're going to be using Windows, there's going to be a different folder which you need to go into. So Linux x86, and like I said, like build options, we didn't really provide any, so it built everything. But there are two folders which correspondingly get generated: debug and release. And debug has more functionality in terms of like stepping through simulation when you're actually trying to debug things, maybe on the action graph side, or maybe on your code side, or maybe even in terms of like things which have been failed on the debug on the build step itself. So that is something you could look at. Usually the one which you're interested in is in release right here. So as soon as you open this folder, I think this is where you start to see like this is what you usually get when you've got ISXM installed. So for example, if you use 4.5 and you followed the installation steps from the website directly to install ISXM, this is what you get directly when you unzip your installation, because like this contains everything which is built for you. So you'll find your extensions, you'll find isaacsim.sh, and you'll find like the python.sh as well, which is responsible for like running isaacsim. So all that is available right here, and this is like usually what developers have been able to see towards the end, but now they've got like more control and more visibility even on the source code end of things. So any questions, Eric, here, or do you want me to go ahead with
Oh, I
actually
just
opening
think there's
isaacsim
something
up?
about building something like this yourself that makes you feel really like a hacker, like really
Yeah, yeah,
cool.
it does. Especially when you see like the terminal being logged continuously. As long as it doesn't fail, I think things usually are good for you. But when it starts, like when you run into compilation issues, for example, and you can't find your way around, then not so much fun anymore.
Yeah, yeah, that's for sure.
But yeah, we've got isaacsim now ready to go, and let me actually open up the terminal again. So we build process went in fine. I'm going to navigate to the build directly. Linux release. Let me check that looks right here, and I'm gonna run isaacsim. So we can see at least even the window has been updated. It's now 5.0, which is being built and run. So things have changed a little right here. So this is basically, this is something which anyone can do even right now. So for example, if you're following along in the office hours and you have like the prerequisite setup from your end, and you actually go through the build process and run this is what you're going to see. Like it's the same for you as well as me. So most of the GUI is more or less the same. Things have not changed around much. You will be able to see, you'll be able to find all the assets right here with isaacsim over here under like your content window, where it's going to take a while to load them because it's going to pull them in the first time it's being run. So those corresponding assets will show up soon, but they should be good to go. So look at the extensions right here. You'll see all the extensions which are already enabled by default. And if someone is actually curious in terms of like where these extensions come from, or how can I understand more what's happening, let's actually go back to the GitHub repo. Uh, Here we are. So there are a few files that you can actually take a look at. So if we go into, for example, source, and we look at apps, I'm not sure if many people are familiar with this or like have actually taken a look at it, but there's a kit file called isaacsim base experience.kit, the one right here. Let's actually go ahead and open this up. So this is going to show you more details about like what's happening under the hood in terms of extensions and settings. So like we understand that IsaacSim is built over Omniverse Kit. It's got like its own set of extensions and sensors, settings, functionality, which enable you to like simulate robots. So it obviously leverages a lot of extensions for the entire workflow. So you could be using Replicator for SGG. You could be using like the ROS bridge for working with ROS, and you'll be using physics-based extensions as well for simulating robots. So this is where you'll find all of them. So this is the base kit file which specifies the package, which is like the base IsaacSim app. It's the version is right here, and these are all the extensions which are going to be enabled by default with this base IsaacSim version. So you'll see a lot of them right here. Let's scroll. So sensor RTX, for example, it's enabled by default. You've got physics sensors, you've got cameras, you've got surface grippers. The robot schema is also something which is of interest, and that's relatively new with the 5.0 release. And if we have time, we'll quickly go through what it entails. But all the extensions which are part of like the base IsaacSim kit app experience, those are populated right here, along with some settings as well. So you've got the IsaacSim extensions. You also have Kit-based extensions as well. Kit comes with its own extensions, which are already available there. So those are also being used as a part of IsaacSim. And then you've got settings as well. So and you'll be able to read the comments for like multi-GPU. Some of them have been enabled, disabled, depending on performance, some particular settings for physics time steps and stuff like that. So you've got a lot of settings which you can look at. And I would recommend, if you're like interested more in terms of like what happens under the hood when you actually run IsaacSim, to take a look at like the default extensions and settings which are enabled. There might be a time where you want to tweak it. So I remember like initially during like maybe like 2 years ago on the IsaacSim days, like ROS1 bridge was standard, and I wasn't really much of a ROS1 user. I was like a ROS2 user, and how it might sound trivial, but I don't like going into the extension manager, disabling ROS1 bridge and enabling ROS2 bridge like every time I'm running IsaacSim. So actually just going ahead and commenting out ROS1 bridge over here and highlighting ROS2 bridge when I enable it gives me total control over like which extensions are enabled on startup. So smaller things, but yeah, depending on what sort of level you're using IsaacSim at, that might be of interest to you. So this is like the base kit file for IsaacSim, and the one we're actually running right now is the full kit file. So it depends on the base. So it inherits like the base kit file, which we just saw, which has like all the extensions, but then it's got many more, which are useful from the physics standpoint, from sensor standpoint, from replicator standpoint. So you've got the other extensions available here as well, along with a few more settings as well. So when we do actually run IsaacSim right now, for example, when bring this up right here, so it's like IsaacSim full, and let's go back to that kit file, and you should be able to see the same thing as well. So this is IsaacSim full, so it basically is telling you in some sense that the kit file which is being used for like running that IsaacSim application right here is using all of this which is being referenced in this particular file. So it was interesting for me when I learned more about this. Eric, were you familiar with this by any chance, or new info to you?
It's I was familiar with it a year ago.
Okay. Nice.
And because I was starting to write a few apps, but I think they've cleaned it up a lot since I saw it last. And it looks a lot easier to use than when I saw it last. Especially like being able to inherit apps like that makes it really kind of easy. I'm just wondering so IsaacSim, it's more like source available right now than open source. And that means that you can see the source, but you can't contribute yet. Is that right?
Right. I think that's correct, and that's a good point which you just brought up. So right now the current state is like, so like we understand like IsaacSim is built over Kit, and it comes with its own set of extensions, its sets of workflows, and importers, exporters, sensors, like all the things which are basically needed from like a robotics perspective to have a simulation running. So that entire layer has been open sourced. So in the sense that I can now go and look at the source code, I can look at the extensions, I can look at tests, I can look at tools, I can look at everything, even the build process. But the lower level kit stuff over there, like that is still closed source, and that has a different licensing model as well. And that is something which is mentioned even in the blog right here. It's that Isaac Sim is available and can be customized as per like a developer's experience and needs. However, the underlying Omniverse kit based things which are there, like those are still closed source, and they require redistribution rights if you want to build on top of it, and maybe have different applications and products based off it. So I think there's a slight difference over there. But from mostly the robotic standpoint, if you're interested mainly in the ISXM side, understanding like what are the core API things which are happening at the back end, how is physics running, what are replicator things above ISXM which have been built for your use case, all of that can now be seen, and we can actually walk through, actually go through the code in
Well,
some sense over there.
someone even asked about using their own custom physics their own rigid body physics engine with Isaac Sim.
Hmm.
And that will be possible at some point using
Yep,
Newton.
yep,
Is that in
yep.
Isaac Sim 5.0 or is that in
No,
a
no.
future release of
So
Isaac Sim?
that should happen in a future release of Isaac Sim, where I think even when we had like the office hours, for example, like some time ago, it was like the vision is that you'll be able to have like plug and play with different physics engines for Isaac Sim. So you will be able to have like Newton, for example, or the current physics engine. So you'll be able to swap in and swap those out depending on your use case. So that is something which will happen later. Right now, it's tied to NVIDIA physics engine.
Well, and even with Newton, so right now there's the NVIDIA PhysX based engine that's in there.
Yes.
In the future, there will be um, Newton where you can choose any one physics engine.
Yep.
And then in a later release at some point, you'll be able to choose multiple physics engines and to do multi-physics.
I think that's the plan. Like we can certainly circle back and check the roadmap for that, but at a high level, it's like currently we have the physics engine which is built by NVIDIA, which is directly supported, and with Newton, which is going to be using like built over Warp, and that is going to be like something which is going to happen maybe a few months down the line. That support will be added in Isaac Sim, and then like you mentioned that in general, bringing in your own physics engine, that is also probably on the roadmap, but I'm not really sure what the timelines look like for that.
Well, and I think my understanding is that being able to bring your own physics engine in, that'll be kind of like, right now you can write your own renderer for Omniverse and you can plug it in, but you only run one renderer at a time.
Yep.
And I think that they'll definitely release the ability to write your own and integrate your own physics engine
Right. I think it's going to
before
be,
they have the multi-physics support down the road.
yeah.
Yeah,
I think it's going to be a little similar to like how you mentioned with the rendering stuff, even with Omniverse right now. So for example, you can select path tracing or real-time tracing mode, or you can select like iris. So you've got like a couple of rendering options to select from. I
yeah,
think maybe physics also might follow a path similar to that, but however, for now it's going to be like only physics and then like Newton maybe in a few months, and then further from there. So that is
yeah.
something which is like going to happen later. We are not entirely sure right now what things might look like then.
Oh, we've got a great question. Is it like how do you create an app, or is it possible to write or integrate your own components? We're getting some good questions about people who might want to develop on top of it. Well,
Yep.
to create your own app, you could either start with Kit, and there's a Kit app template, and there's some
Yep.
instructions on the Omniverse homepage that explain how to make your own instance of the Kit app template. Or you could fork Isaac Sim and start with that as your template,
Yep.
start from there. And
Yep.
then is it
So
possible to write or integrate your own components? Absolutely. So if you look at Isaac Sim, you see all of those line items in that Kit file. Each one of those is an extension. And I'm not sure which ones are or aren't, but many of those are open source. I'm in that repository, so you can see how they're written,
Yep,
and then you
sure.
can
I
write
think.
your own extensions and include your own extensions.
Yep. So I'm back into the i6sim repo and I've gone under source and extensions right here. This is where you'll be able to see all the extensions which are like a part of i6sim, like their source code. So that is something you can certainly take a look at. And I think usually we've had like a lot of interest on the ROS side. So let's actually go under the ROS2 bridge. So you go under the ROS2 bridge, there is a README for basic usage, which is enabling the extension from the extension manager. So that should be good enough. And then you've got nodes as well. So OmniGraph nodes, for example, that was something which we covered last time. Uh, how do they actually work from the code perspective where you define the OmniGraph nodes itself, which is in a certain format. So they're .ogn files right here. So that tells you that this is the node, this is what sort of functionality it has. And then you specify what sort of inputs are needed for like running the node and what sort of outputs the node gets. So if you remember like the node itself where we were drawing connections like the noodle thingies between like outputs and inputs of two different nodes, those need to be specified in this OmniGraph node OGN file right here. So this basically tells you that this is an OmniGraph node for creating a ROS2 context for a given domain ID. That's the description of this corresponding node we're looking at. The inputs for this particular node is the domain ID of the ROS context. You can set default values for that. And you can also use the environment variable, which can be provided before you start ISACSIM. And then the output is the context itself. So this OGN file gives you a higher level overview of the inputs and outputs and the functionality of that particular node. And then obviously you need to implement this. So this needs to be implemented as well. So you could implement them in C++ or Python. And let's actually go ahead and look at, so this one is implemented in C++ right here. So I opened the same file, I'm sorry, lost to context. So when you actually go over here, you will be able to see at the source code for that corresponding OmniGraph node. So you will be able to see, so for example, in OmniGraph nodes, you need to have the compute function defined, which is basically responsible uh, to activate the node whenever like it's being connected to the relevant nodes upstream and downstream. So as soon as the node enters like the fire state or basically when it's being executed, this compute function is going to be run on loop. So as long as inputs and outputs are taken care of, it's going to look for resetting the context node and then it's going to check which of the inputs are provided and then correspondingly set them up. So I would strongly recommend to understand like what's happening under the hood now that the open source release for ISACSIM provides you with all the source code which is available. You can look at everything. So like transform tree publisher, for example, like what's happening under the hood. So for example, for transform tree, what it needs to do is like needs to query the physics APIs to understand where are the current joint states at, what are their positions and all the relevant things are transformed. So pull that in from the ISACSIM physics API side of things, convert it into the ROS corresponding versions and then actually publish them out to ROS. So at a very high level, all the ROS nodes are actually doing something similar. Pull things in from the ISACSIM side, convert them into something which is compatible with ROS, and either publish or subscribe to that information and go back and make changes on the simulation side. So basically that's what the bridge does. And now you've got access to the source code as well. So for example, writing your own ROS2 contact sensor is something you want to do. What you can do is like once you've cloned this repo, I can describe my own OGN file for ROS2 contact sensor, which basically might say that as soon as my robot hits a wall, I'm going to publish maybe a string saying that robot hit wall. That's a very trivial example, but that is something which you can now define by your own self as an OmniGraph node over here, and you can implement it and you can define it, and when you build it, it's going to show up on the extensions as well when you have roster there. So you
You know,
entirely have like complete scope over that.
I wonder if a use would be game to join us on a
Yeah,
live
I
stream
think
and
he
just
would
like
be.
go over the ROS2 bridge. And now that
Yep,
it's open source, you
yep,
can just like show people how it works.
yep, for sure. So the ROS2 bridge was just like one example which we have right here. So all
Yeah.
the other extensions also which are a part of ISACSIM for physics, for cameras, for core APIs, all of their implementation is currently available. So Python files, C++ files, all of them, you can like go and look at them. And I think also serve a very good reference for people to actually build on top of it. So once you understand like what's a good practice to follow in terms of like writing your own extension or your own OmniGraph nodes, because like they are completely open source right now, you can follow like those best practices yourself. And if that is something of interest to the community, I think Eric, that is something which we could also cover, like writing your own extensions and your own OmniGraph nodes on top of the current ones which are already available with IsaacSim. We can certainly show how that can be done. So all the source code is basically available for you to look at, and yeah, basically understanding what each extension does at a high level is something which users are already familiar with, but now you can actually go in and see what's happening behind the hood for the code itself. So it should be
Yeah.
interesting if you want to actually have a deeper dive in terms of how things look like.
If people are interested, I think that, or if there's some other extension that people are interested in, we could invite the engineer to join us one week.
Yep, for sure. Yeah,
You know,
we can have that arranged as well. So uh,
we're getting some great questions.
sure, we can take a
Andrew,
pause and have questions answered.
yeah, Andrew is asking about industrial protocols like programmable logic controllers.
PLCs.
Yeah. Do we
Yeah.
support PLCs in
Mm, I
Isaac?
don't think like there's direct support right now in terms of extensions written, but I think there is something which is going to be coming soon in terms of like extensions which have PLC support, but that is something which we can circle back internally and sort of understand better from our end. But I think it's on the roadmap. I'm not really sure of timelines.
Well, I think the thing that I heard, well, and man, sometimes I forget what's on the roadmap or not, to be honest.
Yeah.
But I think that there's certainly, and you could certainly write your own extension, right?
Yep, you can. Yeah.
To kind of mimic whatever PLC you're using,
Yeah.
and you could certainly, you know, use. Well, I don't know how well Ross would mix with PLCs, but
Yeah, I think we've got Shane also. I think Shane worked a little on the PLC side of things and he's helping answer questions there. Thanks, Shane. He mentioned that there are a few open source extensions for PLCs out there, including Backroff and BNR. So I'm not very familiar with the PLC world, but I think we have some support over there. But yeah, depending on the providers as well, I guess like things might change. So, but there has been some exploratory work for sure, which has happened.
And then Tom Bombadil asks about a little bit about licensing. So he asks,
Mhm.
if you build a custom extension / app, you can or cannot redistribute. And I would say that my understanding is if you write a custom extension, you are not redistributing IsaacSim anyway. People are installing IsaacSim and then they're adding your extension to it. And you can go ahead and monetize those extensions if you'd like. Come up with your own way of doing that. If you want to have a white label app, like your own, not IsaacSim, that does robotic stuff, well, then you would need some sort of redistribution licensing. I
Yep.
do have to say the folks over here that work with that sort of thing, they're really nice and they want you to succeed in your business. And I would not, if you're working on something, reach out to us and have a chat with them. And
Yep.
you know, so we're all about building wins. We're not like trying to lock things down. We're trying to craft wins for everybody and help
Yep.
grow a whole new, all this robotics business sector. And yeah.
Makes sense. I think we also have a nice question like about do you have any plans to add ROS to bridge support to Isaac Lab? I think that's an interesting question, but I'm not really sure of like the implications and scope of it because with the latest release of Isaac Sim, we are going to be having more samples around like ROS for policies which have been trained. But so basically how it's going to be is like you set up your robot USD, you make sure it works as expected, bring it over into the Isaac Lab world, train it to do a certain task. And the interesting part or like the real part is where you need to deploy it, right? So there can be like two or three steps intermediate to that. So once you've trained your policy, you might want to be running it with Isaac Sim and software in the loop to basically make sure like the policy works as expected and it's handling like corner cases or things just showing up on the simulation side as expected. So That
Well,
can
and
be
you
done.
might even need to use that simulation to capture a data set to
Yep.
train your own state estimator. Because a lot of times in Isaac Lab, we train with privileged state, stuff that you don't have access to with your real sensors. And so, but
Yep.
sorry, carry on.
Yep. So once you've trained your policy and you now want to evaluate it without inside the simulation world before you even actually enter the real world problems or domain, you bring it back into Isaac Sim. You can either go through the extension based workflow. Actually, let me pull up the docs right here. Uh, Isaac Sim logo. We've got sample Isaac's deploying policies in Isaac Sim. So this is like one of the first steps where you've trained your policy and you bring it back into simulation. So for this example right here, where we've got like the humanoid walking. So at a very high level, what it's doing is that I think that's something which is also covered by Steven and Oenda in their Isaac Lab office as it's similar to that where
Yeah.
you've got your train policy, which is like a PyTorch file, bring it into Isaac Sim, and now for your policy to execute or basically run, you need observations. So bring in those observations through Isaac Sim API. So you might need your IMUs, contact sensors, and joint states, for example, as your observations to the policy. Use the Isaac Sim APIs to read that, pass it into your policy. Your policy is now going to give you the action which is needed to be executed. Take those actions and apply them to the robot through the Isaac Sim API. So at a very high level, that is software in the loop where trained a policy in Isaac Lab, brought it back into Isaac Sim, and connected it up with the relevant API so that I could have like observations and actions being run as expected. So that is like the first step of software in the loop. Now, the interesting thing is like if you actually want to deploy on the robot, then you want to shift over to the framework which the robot is using, which could be ROS, for example. So now what you might have to do is like you've got ROS nodes which are going to be responsible for getting access to the joint states. You might be having ROS nodes which are receiving like the camera data or IMU data. And you also need to have a ROS node which is going to be responsible for running your policy, which you've just trained. So you can still have this entire framework being done in software in the loop where instead of using Isaac Sim APIs, now I'm going to inject ROS over here. So I'm going to use like the corresponding ROS OmniGraph nodes for getting access to the joint states, the contact sensors, IMUs, and all the observations. Going to pass it into a ROS node, which is going to run the policy, and it's going to provide the actions as well towards the end, and that those can be executed through ROS. So you've got ROS set up with software in the loop. You can also do hardware in the loop. So if I have a Jetson, for example, and I want to see if my Jetson can handle running maybe a policy, and your robot may be also detecting like objects around it, could be running segmentation networks. So understanding if like your hardware is good enough to run all the software algorithms on top of it is something which is useful, and you can use hardware in the loop with ROS for that. Now you've done everything you can before you actually move to the real robot. And the final part is hopefully using that same framework which you developed in ROS, just pick it up and put it onto your Jetson, which is connected to like the entire real robot sensors, and see how it works. And if you need tweaking and fine tuning over there post training, that is something you might have to do. But at a very high level, the workflow probably looks like it. Uh, have your USD asset or have your robot model in CAD or URDF wherever you want it. Bring it in Isaac Sim, make sure like physics is behaving as expected. Take it over to Isaac Lab, train it to do a certain task. Bring that policy back, do software in the loop, make sure everything works as expected. Do hardware in the loop if you want, and then bring it onto the real robot. So I think at a very high level, that is what is going to be involved for like end-to-end sim to real sort of a deployment. And we could certainly take a deeper dive into parts of those depending on interest from folks. But hopefully that answered the question.
Well, and I thought the same. I thought similarly to our viewer when I started. I thought, well, how am I going to train Isaac Lab directly with ROS from the get go to simplify my sim to real deployment? And the answer is that most people don't do that. Most of the researchers who are doing sim to real, they're training just this discrete policy in that's with kind of simplified observations in Isaac Lab so that you can get your RL to train and optimize. And then they use Isaac Sim to kind of deploy that policy. First, they just deploy it directly and use that privileged information in Isaac Sim to make sure everything's working. And then then there's a design process of weaning the robot off of that privileged data and switching it to sensor data. And they're doing that with direct API in Isaac Sim so that they don't have to worry about any of the complexities of ROS or any of that stuff. They're trying to
Yep.
kind of do that design work in the simplest way they can. And then once they have like a policy working with whatever other code, maybe a state estimator, maybe some kind of sensor data processing, whatever that, maybe a state engine. Once they've got that working, then they work with ROS. Then they start to write the ROS nodes
Yep.
and maybe look into, well, let's start to simulate some of the latency. Let's simulate some of those real worldy kind of things.
Yeah.
And maybe they do have to go back and find a way to simulate some latency in Isaac Lab. But that's kind of, I thought I was naive and thought once I've trained a policy in Isaac Lab, it's good to go. Let's deploy that sucker. And it's just not
Not
that
so
simple.
sure. Yeah.
No, I had no idea. And
And just to add to what you said, Eric, I think you brought up a very good point. Like the pieces we just discussed, like from the end-to-end perspective, like those probably need to be followed in a sequential way where you make sure like the first piece where you're currently at works as expected. Because like if your
yeah, it's like
policy
looping
is not
back
going to
after.
work, yeah, exactly. If you've trained a policy but your policy is not doing great anyway, then even software in the loop is not going to work well. So
Yeah.
you can certainly deploy it on the real robot, it won't work. So that's probably
But
not
if you're
going to be
trying
the
to do
point.
all of it, like with ROS and the latency and
Yeah.
everything from the start,
Yeah.
you're just going to give yourself headaches.
Yeah,
And
yeah.
yeah.
You should certainly be tackling it piecewise, and the most important pieces to solve are like bring your robot in, train a policy which works well enough for your use case, and then actually go into the realm of like testing that policy and figuring out like latency, sensor configs and stuff like that, and deployment. So, but
Well,
if you
and even
don't get to the,
actuator configs, right? You got like
yep,
there's
exactly.
like so much. To be honest, it kind of gives me a headache sometimes. There's like so many things to configure and like,
Yeah.
I'm like, and sometimes I don't know. I'm like, well, can I just, for example, with a given actuator, do I need an actuator dyno to like nail down the actual actuator properties, or can I just use domain randomization
Yep.
to make my policy more robust?
I would say
And
domain randomization of my experience, but probably both maybe if you can.
yeah, I mean, yeah, domain randomization is a lot easier than building an
Yeah,
actuator dyno.
you can't really know with, I guess, like 100% certainty, like even going from like real to sim, like these
Yeah.
are my motor config files, or these are my actuator config files, and I want an equivalent mapping of them with a physics engine which has like XYZ features. Like there might not be certainty of one-to-one mapping there, and I think like that is like the general premise of domain randomization, right? It's being able to handle those uncertainties or like noise or like variations for parameters so that like the policy or your model trained is still robust to it. So
Yeah.
that makes sense.
And I think that owning that there's going to be this iterative design process,
Yes.
and just owning that process will help you get a handle on instead of trying to solve all the problems at once, but just owning it. I'm going to solve one problem at a time will really help you understand each problem, will help you decouple the issues, and
Yes.
you'll end up with a better working, more elegant solution. And over time and with experience, I'll bet you'll even develop a relatively efficient pipeline.
Yeah.
Whereas if you try to do it all at once, you
It's too
might get
much.
one to work, but it'll be very mysterious. And
And I think you'll also get
yeah,
a lot, it'll get very overwhelming on the way because like there's so many knobs which can be tweaked. It's like going to be very difficult to understand that if my robot slipped and fell in the real world, like was it a
yeah.
policy problem, or was it a latency issue, or was it a sensor issue? Like the
Or was it my, or did I have the wrong hyperparameters when I
sure.
trained my policy? I mean,
Yeah.
man, is there so many little,
There are too many things which could like go
yeah,
wrong. So if you don't like independently understand each piece of it and like just try to bring it all together saying that this is the workflow and it should work this way, it might not go as expected for sure.
yeah.
Or a
It's a
bolt
great,
loose. Yeah, Shane, good idea. Bolt loose.
Oh, that's kind of a cool comment. Okay.
great,
Yeah, that's
great
really a
comment
great
here
comment.
from Shane in the chat. Testing robots in real life is expensive, risky, of course necessary, but steps we're talking about can massively de-risk robot commissioning. That totally
Well,
makes sense. So thanks, Shane.
well, and the thing about artificial intelligence is that these are linear approximation models, and so they're statistical models, really. And if you know, and the thing about statistics is statistics can interpolate very well. It just can't extrapolate well. And what I mean by that is when you're training your models, if you kind of randomize like your actuator properties and your friction properties so that they're out of bounds of what you'll ever experience in the real world, then your model should be able to interpolate to what happens in the real world pretty well. Where you get into more trouble is if you spend all this effort trying to model things very accurately, but you end up inside that envelope of what you would experience in the real world, your model will not be able to extrapolate outside of that test data. So you're better off with a little bit wider randomized domain that your model can interpolate inside of than having a very accurate simulation that does not represent a large enough space. So
Very nice. Well, gentlemen, that time has fastly approached. We covered a full hour, unless there's anything you want to give any parting words with before we say our
I
goodbye.
think we had a question about like SDG updates. There were certainly more things I was hoping to show, but I think like we had a lot of good questions coming, so we could certainly cover that. Like I think one of the important thing which I wanted to cover was like there's a new writer with Replicator, which is like a Cosmos writer, and that is pretty cool. So I can actually share my screen
Yeah, that'd be
real quick
great.
and
Yeah,
maybe
go
take
for it.
1 minute
Yeah.
overboard, but yeah, instead of actually
like an
going through the
encore, right?
tutorial, I'm just going to go through. Sorry, yeah. Yep, thank you. So if we actually look at the blog which went out with the release stuff for Isaac Sim as well. So we've got advanced synthetic data generation pipelines also. So there is mobility gen also, which is now directly supported with Isaac Sim. So that allows you to like teleop your robot and have it like even like move around and plan paths and gather data in that sense. And it scales across different robot embodiments. So like humanoids, quadrupeds, AMRs. So this was initially released as an independent project of Isaacson, but now the team has worked to actually bring it in over as like something which is officially supported as an extension. So that's certainly something of interest if you're looking to scale up your SDG for different robot embodiments and synthetic environments. And there's also a few things on the Metropolis end where replicator-based SDG for actions and events. So mostly for like human robot interaction sort of situations where you've got like people moving around in warehouses and incidences or events occur, like you can have specific synthetic data generation pipelines suited for that. So those two are something which you can look at. And we've got improved data format compatibility for Cosmos. So we also have a tutorial for that, and maybe next time in the office hours we can cover it, but it's basically how you can prepare a data set from Isaac Sim using a Cosmos writer with Replicator. And once you're actually able to do that, this was something of a tutorial where we were going to walk through, but we're a little short on time, so we can have it next time. But it's basically going to have three inputs for Cosmos. So it's going to use depth, it's going to use canny edges. So if you look at the image right here, so this is like the left one is the depth image, which is obtained from simulation. The right one is a simple edge detector, which is responsible for giving you this sort of a representation. And the one on the bottom left and bottom right are shaded segmentation and instant segmentation masks. So all of these can be combined as multimodal inputs for Cosmos and provided in as a video. And you can prompt Cosmos to actually generate data for you. So pretty cool results down here. So you can provide like a prompt right
Does it
here.
show any of the results that Cosmos does? There's like a little
Yes.
video below.
Yes, there is a video below. I was just quickly showing the prompt,
Oh yeah,
like
yeah.
what the prompt looks like. And we have like the input videos which have been generated from Isaac Sim with the help of the writer, which is a part of Replicator. And here is what you get from the Cosmos standpoint. I can replay the video, but once you've got like the instant segmentation, shaded segmentation, and a few other modalities, passing in the prompt in terms of how you want the data to be generated, and then Cosmos is going to generate like the photorealistic data for you. So even you've got more
Okay.
samples right here where like you can change the clothes of the worker, for example. You can change the visualization of the forklift, the environment, the warehouse. So there are a lot
And
of
that's
things you can play
Cosmos.
around with.
Is that Cosmos Transfer?
That's Cosmos Transfer,
'Cause
yes.
I think one thing that confused me at first is that Cosmos is not one model.
Nope.
Cosmos is a platform of
Yep.
world generation models, if you will.
Yes.
Yeah.
So this was an interesting thing as well, and we can certainly cover this maybe next time. But at a high level, it's basically being able to generate data from Isaac Sim using replicator and a new writer, and that the data generated from that writer can then be passed into Cosmos, which can like scale up your SDG for photorealism as well. So it can be pretty cool. So for manipulation related tasks, for warehouse AMR navigation, for humanoids, I think like applications are endless.
So cool. I can't wait.
Amazing.
Yeah, I want to use Cosmos Transfer to. So I've got this idea of training a robot for RL, training up an RL policy for a robot, and then using privileged data, and then use Isaac Lab to kind of train to capture a data set to train a state estimator to estimate that privileged data instead of using sensor data. So just use basically camera and then I think to transfer to real world, I'll want to use Cosmos Transfer to take that same data set that would work just in Isaac Sim for a state estimator and augment the data set for a real world state estimator. Anyway,
Sounds cool. Yeah.
yeah.
I think these were the main things I had from my end to cover. Yeah, if there are more questions we can help answer, or I think we're good, then we should be in
What
good
do you say,
shape.
Eric? You see any juicy ones there you want to take?
Mm,
Oh, let's see.
Why don't you guys look for a quick second while you're looking? I'm going to share my screen because I wanted to share a.
Sure.
Oh, go ahead, Rishab.
No, sure. I said sure. Go. You can share
Okay,
your
good.
screen.
I think
I'm going to share my
McKay
screen.
asked a great question. He
We
just
saw.
asked, I
Oh, go
think
ahead.
we need like a session, like a what can we do with Cosmos right now session. And I think
Yeah,
that's a great,
makes sense.
yeah, great idea for a session.
So we'll plan that. I posted the event calendar. So for folks who want to keep track of our upcoming live streams, our office hours, our study groups, big events, and keynotes, there's an Ed event link I posted in the chat. You can subscribe to the Omniverse calendar there, or just check it out at your convenience. You'll see what's coming up next week. Actually, we haven't posted this yet, but we'll post it I think later today. And during this time next week, we're gonna have Media Monks joining us. We're gonna talk about using AI for ad generation. Should be super cool. They have a lot of awesome stuff they're going to show. I got a sneak peek at it yesterday, so definitely tune into that. But I wanted to share what's on the screen right now. This was just published a few hours ago from Kabalan. He's an awesome developer based in India doing really cool work. And he just posted a Medium blog on how he's leveraging Isaac Sim and Isaac Lab. And the Medium blog goes into how he's training a humanoid robot to walk. I posted the link in this chat. If you missed it, feel free to just go to Kabalan KB's LinkedIn page and you will find it there. But basically, he links to this Medium post here, which is public, so everyone can access it. But a really great developer. I highly recommend you follow him on LinkedIn, just regardless, because he's just a fantastic developer and always sharing great information. And then we also have while on LinkedIn, I would highly recommend following FS Studio. Our Omniverse ambassador, Muammar Bey, just started working with the FS Studio recently, producing amazing content, including this demo on here. I know we're talking about Isaac Sim today, but this relates to Isaac Lab. Again, teaching robots to walk this one across through rough terrain with one command line. Very cool. So go to the FS Studio LinkedIn page. You can find this as well. Highly recommend that. And then Eric, did you find a good juicy question you want to take?
No, I just saw something in that video. They're using SKRL, which is easier to train with in Isaac Lab and get started with, but you want to use RSL-RL for later on once you're deploying to Isaac Sim for software in the loop. Just something I learned in a recent session.
Yeah, that's Marma's voice. Okay, cool. And then finally, let me see. We have AI for all happening. I'll post a link in the chat. This is for basically students and educators. I'll post this in the chat, but there's a couple of really great sessions coming up. These are part of the NVIDIA webinars series. My colleague Max has been working on those. So I highly recommend if you're a teacher or a student, check out the link I just posted in the chat. Super helpful. Okay, we've had a crazy, fun, and very fact-filled, great questions from the audience here. So thank you everybody for tuning in. Do you want to any parting words from either of you two?
Just that Papa Chuck is saying he knows how to get SKRL to work fine. So he must know.
Papa Chuck, so far Eric's laughing, but Papa Chuck is a great member of the community as well. I highly recommend you can engage with him and others on our Discord server. We posted the Discord invite in the chat. You will find him often hanging out in the Isaac Sim or Isaac Lab chat, and also in the study group, which is kicking off in 15 minutes if you're watching live. It's 12:30 p.m. Pacific. Every Wednesday is the Isaac Sim Isaac Lab study group on the Omniverse Discord server. So highly recommend you check that out. Really great group of developers diving into Isaac Sim and Isaac Lab. Strainflow usually attends, and like I said earlier, Papa Chuck, and I think Lychee AI will be there. Here he is.
Yeah, he's usually there.
Yeah,
and
so,
it's really a fun group, and I love hanging out with all you guys. I love your questions.
amazing.
It's so
Well, thank you both of you for coming and sharing a preview to the developer community about this exciting release, open source, and everyone can check it out in the preview. And then it's going to be more open sourced shortly, accepting contributions. But right now, you can check it out, test it out. If if we went too fast, just this video lives on our YouTube channel on the live section. So go ahead and watch it again and pause it. Rishab was really fantastic about showing step by step. So I highly recommend you check it out. And then obviously post any questions for the team in the Isaac Sim channel. Isaac Sim forum on the official forums. If you're messing with Isaac Lab, that's great, but that support area is on the GitHub page. And then obviously you can chat with other community members about Isaac Sim and Isaac Lab on our Discord server. So it's a great place to go for support, whether you're looking for official support from NVIDIA or you're looking for just support from other developers, or you want to share and celebrate your work. We have a channel in the Discord server called Share Your Work. I would love to see your projects. I think that would be amazing. You could share a quick GIF or a video, or just tell us what you're working on. And to be frank, I share what you post in there with the larger NVIDIA team. And don't be surprised if one day someone with the initials JHH comes and checks out your work, because I know that he's always very excited about the work the developer community is doing. So we love celebrating your work. It inspires and motivates us every day. So please share, tag us on LinkedIn. Until next time, thank you so much for joining us. This has been a great time. Rishab and Eric, fantastic tutorial today. Thank you.
Thank you.